In this video, we're going to be expanding on our knowledge of matter by taking a look at different properties of matter, which are simply different characteristics that we can observe or make changes to in order to describe the different type of matter better. And what we're going to start by looking at are the physical properties, or rather several examples of physical properties of matter, which are properties of matter that can be observed without changing what the substance is. Simply put, when we test a physical property, we're going to inflict some type of change or some type of observation of the physical property, but that change or that observation is not going to change what the substance is. So a fairly easy example for us to visualize is the concept of hardness, which simply measures how breakable a given substance is. Now, if we take a look at the structure on the left, this is a diamond, which is actually a form of pure carbon, however difficult and expensive it is to make. Now, we know that diamonds are special because it is basically impossible to break a diamond unless you use high-powered energy like a laser or another larger diamond in order to break it. Now, this means that diamonds have a very high hardness, indeed the highest hardness out of any known substance on Earth. Whereas if we consider chalk, which is a form of calcium carbonate, we'll talk about chemical structures and chemical formulas later, but chalk is an example of a substance with a very low hardness, and we use this hardness because when we take a piece of chalk and write on a blackboard, chalk breaks apart so easily that it leaves a powder on the blackboard that we can use for writing, and this would not be possible if it had a high hardness. Now, why hardness is considered a physical property is when we test the hardness of diamonds and of chalk, if we take a larger diamond and smash it into a smaller diamond to see whether it breaks, that doesn't change the fact that a diamond is made out of carbon. We aren't changing the chemical structure or the identity of this substance at all. Likewise, when we take a piece of chalk and write on a blackboard, even if we're breaking small pieces of that chalk, of the calcium carbonate off, it doesn't change the fact that chalk is made of calcium carbonate. The formula and the chemical structure remains the same regardless of whether it is in solid form or whether it's in the powdered form we can use to write. Closely related to hardness is the concept of malleability. Now, if you aren't familiar with where this word comes from, the root of this word is actually a Latin word which is pronounced malleus, which is the Latin word for hammer, and that kind of tells us what we're testing when we test malleability, which is simply to see whether a substance can bend without breaking. Now, we can see in these pictures here that malleability is very important for blacksmithing and other examples of metalworking because metals have a very high malleability, meaning that when they're hammered, they don't shatter into tiny pieces of powder the way that chalk or this orange powder does, and instead they reshape themselves into a slightly different structure. But once again, let's say that this metal here is Fe, that it's made of iron. Hammering this piece of iron does not change it into a different substance. It doesn't stop it from being iron. However, if we compare metals to non-metals such as chalk or this red powder here, these non-metals have a very low malleability because they shatter into a fine powder rather than being reshaped. A different category of physical properties involve temperature changes. For example, if we add enough heat to a liquid, we can find its boiling point, the temperature at which the liquid turns into a gas. And likewise, if we apply this to solids, we can also find the melting point, which is the point at which a solid turns into a liquid. what we're trying to measure when we find out the boiling point and the melting point of substance is the relationships between different states of matter. Now, states of matter, which we'll talk about in more detail later, are simply the arrangement of atoms of particles that make up that substance. So, ice, we know of, is the solid form of water, and we know that liquid water, well, I just said that it's the liquid form, and then when we make water vapor, it exists as the gas form. But in every case, we know that we're looking at a physical property because the chemical structure and chemical formula of water, H2O, never changes regardless of whether we're looking at ice, liquid water, or gas. The only thing that we're changing is the state of matter, which means that this is still investigating a physical property. Now, in the previous video, we looked at the differences between solutions and mechanical mixtures, and this is investigating another physical property, which is what we call solubility, which is a measurement of how well substances dissolve into other substances. So, for example, if we look at the image on our left, we see that this is a white powder and that this white powder is beginning to disappear within this water here. Now, this white powder could be salt or it could be sugar. We know just from everyday life that salt and sugar dissolve relatively easily within water, and therefore we can say that they are soluble. Whereas if we look at the image on our right, we're looking at oil when it's poured into water, and no matter how much we shake this container of oil and water, we cannot get the oil layer and the water layer to join together, and therefore we say that oil is insoluble when it is put into water. Now, once again, solubility is a physical property because taking salt and sugar and dissolving them in water does not change whether they are salt and sugar. We aren't making a new substance here. We're simply making a solution, and oil and water don't even interact with each other, which shows that there is no change to their structures either. Now, all this changes when we take a look at chemical properties, because unlike with physical properties, with chemical properties, we're actually looking at how different substances change when they react with other substances. Now, we'll talk about what the word react means because it really depends on the two different substances that we're testing. One example of a chemical property is the concept of combustability. Combustability measures how likely a substance is to burn or simply to catch fire in the presence of oxygen gas. Now, if we look at wood here, we know that wood obviously burns if it's dry enough and if we heat it up to a temperature that's high enough, and we know that the chemical structure of wood changes very significantly. So the chemical structure of wood is very, very complicated, but after we burn this wood thoroughly, we end up with black ash, which is basically pure carbon. And because we're going from a very complicated chemical structure in wood to just pure carbon, here we have obviously observed a change in the identity of that substance because we've actually changed the chemical structure. Now, believe it or not, what we're observing in these iron chains here is distantly related to the concept of combustibility. We can measure something that we call oxidizability. If you count that, I believe that's a 7 or 8 syllable word. So if anybody asks, oxidizability. Now, oxidizability measures how likely a substance is to react with oxygen. Now, combustion or combustibility, burning, is what happens when burnable material reacts with oxygen. It catches fire. But in the case of metals, they react with oxygen a little bit differently. They undergo rusting, which is how we can turn these metal iron chains into this reddish brown color. This is what happens when metal reacts with oxygen in order to produce a completely different substance. A very important category that we'll talk about in more detail later is the concept of pH, which simply measures how well certain substances react once they are put into water. So if you consider substances that are sour, like vinegar or lemon juice, these are examples of acids because they react a very specific way when they are put into water. However, if you unfortunately have had the chance to taste what soap or baking soda tastes like, they will taste bitter because they act as chemicals that we call bases, meaning that they react a different way when they are put into water. So in summary, the difference between chemical properties and physical properties are that chemical properties can only be tested when a substance reacts and therefore changes in the presence of another substance, whereas physical properties can be tested without changing what that substance is. So before the next video, see if you can identify which of these properties below are physical properties and which of them below are chemical properties.